Hello, thank you very much for watching this video. Video about the Matlab functions for the first and second order reliability methods. Please log in to reliability.co.nf to download the files. You have options to download them separately, or you can download them all of them at once. That's what I'm gonna do. Once you just download them at once, just make the file extension .rar and extract them, save them in the same folder, and call them through the Matlab. So you are for a first order reliability method, you have a form.p file, which is a Matlab protected code, and the same for a SORM, and you have a setup function which calls SORM or form, and it shows the examples. Also those examples you can just see in readme file, and readme file is pretty important. I described was the procedure and logic of the code and how they work. Please follow them and just read it. If you have any comments, any question, please just email me. So for the input of for the form, we need actually the limit state equation, and the limit state equation input is going to be done by Matlab handle, where the variable are going to be x. So define your limit state equation for the variables x1 until xn, and x1, it means the variable number 1. So in distribution, mean, correlation, or standard deviation inputs, we have to define in the first position information about the variable number 1. That's the logic. And if we have a correlation is handled by native transformation, where the second part of the transformation I just done it through the Cholesky or eigendecomposition. So you can just choose it. So if a native transformation is 0, so second part is going to be done of a native transformation by Cholesky. If it's 1, it's based on eigenvalue. If there is no correlation, so this input doesn't matter, it's going to be ignored. And the distributions what you can choose are going to be normal, log normal, Gumbel, Weibull, or uniform. So for normal choose 1, for log normal choose 2, for Gumbel choose 3, for Weibull choose 4, and for uniform 5. So it's a Gumbel for a maximum value actually, and for a Weibull it's a Weibull minimum value. So I'm showing example number 1. The inputs, it's very straightforward, and the outputs are going to be for form, the gradient vector, design point, and alpha vector, Hasofer-Lind reliability index, gradient vector, and probability of failure. And in this case, the algorithm is working, just searching such that the absolute error for reliability index is met, which is defined by dB by the user, and dz is a difference quotient in numerical differentiation. Another example is example number 6, where we have a correlation, and now we are going to just run it again, and as far as we have a correlation, the native transformation will work in this case. For SORM, the inputs actually it should be the design point coordinates, which we can just find by 4. And once we just have it, we just run it, and we have outputs, Hessian matrix, probability context, and all the information. Please let me know if you have any comments, any questions, and thanks for watching.